Okay, what you see before you is a summary of all the factoring skills you've been learning in this chapter. This little explanation will help you with section 2H, where you have to just factor with all of the different skills you've learned without being told which skill to use when. So here on this screen we have a bit of a flow map. The very first question you should always ask is, are there common factors? And by common, we usually mean common to all of the terms. So if there are three terms, and there's something in common between all three terms, then you would follow this arrow and factor the highest common factor. And then you would continue over here again. There is one other exception to that. If there are four terms, and there are common factors in pairs, so two of the terms have common factors and the other two terms have common factors, then you might be able to use the factor by grouping method, by factoring the factoring we did on a four-term expression. Once you do that, you stop. So the pink circle here means that you're done. Once you've done that, you're finished with the factoring. Okay, if we've found no common factors, or we've already taken the common factor out, then the next step with the rest of it is to ask yourself, do you recognize one of the patterns that we looked at? We basically had two possible patterns. If you see a difference of squares, and this will often happen if you have just two terms that are subtracted from each other, then that's the thing to point out. You've probably got a difference of squares. Then you're going to use that pattern. Or you might find that it looks like a perfect square and it's faster to factor it via the perfect square pattern rather than going the long way. Often we don't recognize the perfect squares. It's possible to factor them without recognizing it, but it is a little faster once you get good at it to do it over the pattern instead of the other methods. Okay, if we don't see any patterns, then we follow it to the third question, which says, is the first coefficient, is the a value in front of the x squared term, is it equal to 1? If it's equal to 1, or negative 1 would work as well once you factor out the negative 1, then you use the sum and product method. That's where we look for what multiplies to the last constant term and what adds to the single x term. If a is not 1, and we've already taken out any common factors, then we're going to have to use the method factoring by splitting the middle term. On these examples here, I'm going to show you that thought process, how we go through the various possibilities in order to solve these. In this first example, I'm going to start with the first question. Are there common factors? Look at each term, and I see that all of the numbers are even, so they at least have a factor of 2 in common. And if I look carefully at the variables, I also see that there is at least one x in every term. So my greatest common factor is going to be 2x, and I'm going to factor out that highest common factor or greatest common factor. HCF stands for highest common factor, but you can also call it GCF. I'm going to factor that out, and then I'm left with x squared. Divide 8 by 2 to give 4. X squared by x gives x. And here I just have a 4. Okay, so I factored out 2x. That's now going to follow through the problem all the way down and end up as one of the factors in the end. But here I still have a trinomial. It's still a quadratic expression, and so I have to think further. That's why I follow this green line and ask, do I recognize a pattern? I see that this 4 is a square number. It's 2 squared. And this is a squared number, or squared value, so maybe I can put this into this pattern of the first thing squared plus 2 times the first one squared times the second one, and then plus something squared. Let's see if that works. Of course, the first part is going to be an x because that's x squared, and the last part is going to be a 2 because 2 squared gives us 4. So is the middle term, if this is x and this is 2, is that equal to 2 times x times 2? And it is, it's 4x. So this one actually works as a difference of squared patterns. So now I'm following it. Yes, it's not a difference of squares. Yes, it's a perfect square pattern. And that means that along with my 2x factor, I have 2 perfect square factors of x plus 2. And I can always show that by just writing it once with a squared line. And then you see the pink circle, so you know that's as far as you need to go. That is completely factored. 3 factors, 2x, x plus 2, and x plus 2. Okay, in this next example, again I start with the first question, are there common factors? There's no number here, so 4 is not a common factor. But m is common to both. So I'm going to start by factoring out the m. And just like the 2x in the problem before, it will follow the problem through all the way to the end. So divide each one by m. Okay, now with what's in here, I should be able to factor further. Let's check. Do I recognize a pattern? Minus sign, and there's only 2 terms. So let's see if we can put this into the difference of squares pattern. Can I subtract 2 things that have each been squared? Here if I put in 2n, and here if I put in p, then that works. 2n squared is 4n squared, and p squared is p squared. So final factors for these are going to be 2n minus p, 2m plus p, and of course the m that I factored out at the beginning. Okay, the next one, section C. I have 4 terms rather than the usual 3, so that's already a clue to say I'm probably going to do this type of factoring by grouping. Are there common factors? Not if I include all 4 terms. Oh, actually, if I include all 4 terms, I do have a common factor of 2. So we're going to start with that then, by taking a 2 out of each term. Could have done this one without that, but it's always best to take out the common factor first. Then with what's left over, I still have 4 terms. They're in groups of 2. If I look at these 2, they have a b in common. If I look at these 2, they have 5 in common. So that's a case with this factoring by grouping. Since I already took a common factor out, my green arrow here that goes all the way to there is maybe not quite right, but we'll leave the chart as it is since it looks so pretty. Let's just keep going and factor the rest of this by grouping. So put it into 2 groups. The 2 follows along, which means I'll need big brackets. In this first section, I have a b to take out, and that leaves me with x minus 3. And this one, I have a 5 to take out. And if I divide each term by 5, then I also get x minus 3. Big bracket because it's all being multiplied by 2. So then in this one too, I have 3 factors. I have 2. I have the x minus 3 that I can factor out. And if I divide each term here by x minus 3, then I also have b plus 5. And there are the 3 factors for this expression. Okay, 2 more examples. In section D, I start again with are there common factors? And either this is just a variable or this is just a number, so there are no common factors. Follow this line through. Do I recognize a pattern? Certainly not a difference of squares, and there aren't any things here that are perfect squares in the numbers. 14 is not a perfect square, 5 is not a perfect square, so I don't see any patterns there either. So I keep following my chart through and say, is a equal to 1 or negative 1? Well, the first problem I have here is that this is not in the right order. The x squared term is in the middle. So I'm going to first rewrite it in the right order with negative x squared first. Remember, the sign belongs to the term that comes after it. Then the x term, and then the 14. And now I can see very clearly that the a term is a -1. There's no other number sitting here. So I'm going to then follow yes, a is equal to 1, and use the sum and product method. With one exception, remember that when it starts with a negative sign, we always factor out the -1 first. Don't have to write the 1, just put a negative sign. So this becomes x squared. That becomes 5x because I've divided by -1. -5 divided by -1 is +5. And 14 divided by -1 is -14, or -14. And now I use the sum and product method on what's left. This minus sign just follows through all the way. So what multiplies to 14? -14, and adds to 5. 14 has 1 and 14, and 2 and 7. I think 2 and 7, if I make the bigger one positive, then I should be able to make that work. So let's make the bigger one positive, so +7. And x minus 2. And now let's check. 7 times -2 is -14, and 7x plus -2x will be +5x. So that's my final answer. A factor of -1, a factor of x plus 7, and a factor of x minus 2. Okay, one more example. Here I go through the questions again. Are there any common factors? This is more like example D that we did up here. Either a number or variable parts, but none of them have common factors. Don't see any patterns, no difference of squares. This would be possibly a perfect square start, but square root of 5 is going to get messy, so we won't use the perfect square pattern either. So I'm now down in this last question, is a equal to 1? A is not equal to 1, it's equal to 4. So I'm going to go this way, and this is a factoring by splitting the middle term. So factoring by splitting the middle term says multiply a and c together. So I have to get 20. And then I need two numbers that multiply to 20 and add to 12. So go through the factors of 20. 1 times 20 won't do it. 2 times 10. There we go. 2 times 10 is 20. And 2 plus 10 is 12. So that's what we're going to need. And remember, we split the middle term with that. So 4x squared plus 10x plus 2x plus 5. Then I factor by grouping. Can take out a 2 and an x in the first group, and I'm left with 2x plus 5. There's nothing in common in the second group, and it's exactly the same as my bracket here, what's in the brackets there, so I'm going to take out a 1, and then I have 2x plus 5 here as well. So then I have two factors, 2x plus 5, and 2x plus 1. Okay, you're ready to try the exercise 2H and see how good you are at recognizing which skill to use when. Feel free to do lots of practice on this because it's what you need to do well on the test. I'm going to circle my answer yet, and that's it.